I will have a pleasure to present today SIOS data. I will talk something about SIOS core data, SIOS core data candidates, also about the data that we are collected through the SESS report and access core. On the second part, we'll go through the metadata collection form, the tool that has been developed by SIOS to help create discovery metadata and make data findable and accessible from the data centers or servers that are not connected to SIOS data management system. And in the last part, we just wrap up your experience of using the metadata collection form, and I will give you a brief introduction about the analysis ready data. So as you know, SIOS data management system relies on the idea of open and free data share. We follow the FAIR standards, and we are delivering some workshop trainings and services for our partners. If you are more interested about how it works, please check our material from the first training when Oystein Godoy, the SIOS data manager, present how it works. For short summary about that, the SIOS is focusing on the Earth system science. So in order to support this effort, data and products describing the relevant processes are required. This can be a result of long-term monitoring efforts or ad hoc efforts focusing on process studies. We are not intended to centralize all this data, but rather to establish a virtual data center offering unified access to relevant data. SIOS data management system relies on the principles of distributed data management. The data sets that are relevant for SIOS as well as their associated metadata are managed by the several physical distributed data centers, and each data center has its own set of data management facilities for ingestion of the new data, maintenance of data sets, and data curation. So at this moment, we are able to harvest and ingest the data from the several repositories. So we are integrating the existing data into a unified system and linkage into the larger frameworks. And as I said, each data center has its own procedures, technical solution tailored to the needs of the data centers, but we are support to follow the proper standards, harmonization, and FAIR principles. How we are doing this, you can easily find this information in our documents. On our webpage, you can find documents related to the SIOS data policy, SIOS data management plan, also SIOS interoperability guidelines, and best practices in sharing the data. But the main principles of sharing data is, as I said, full and open exchange of data and metadata and products shared within SIOS and also with the whole scientific community. All shared data and metadata should be made available through our data management system, so through our SIOS data access portal with minimum time delay and minimum cost. And all of that is free of charge or no more than the cost of the reproductions. Of course, we have in mind that data access may be restricted when data release could compromise the confidentiality of human subjects or cause harm to endangered species or other valuable subjects. You heard a lot about FAIR data, so findable, accessible, interoperable, and reusable data. We are quite good in making data findable and accessible to proper discovery metadata, but the challenge is how to make data interoperable. So how to have a machine readable format of the data or deliver the proper servers to exchange the information about the metadata between different systems, and then reusable of the data. We are working on that partly by the NVFAIR project, when SIOS and our partner and our members are the partners. But going into details about the SIOS data, Data products addressing the identified key research questions in Earth system science are the core products and services for us, for SIOS. However, it has to be kept in mind that due to the limited geographical extent of the SIOS region, Earth system science monitoring and observation activities have to be limited to regionally accessible and relevant variables, which can be expected to change over a timescale of years or from years to decades. There is another aspect for the data from SIOS perspective. SIOS members have to follow the SIOS data policy, which follows the FAIR principles closely. A central element of this data policy is that all data are free and open, as I said, and SIOS data also include high-order products, level 3+. So you can see that we have a different type of the data set in SIOS. It could be historical data, long-term monitoring data, data sets from the single experiments, and data connected to the SESS report and access code data. And this data from SESS report and access code, of course, are usually data from the monitorings or historical data. In the middle of all of that, we have the SIOS core data, which I will focus a little bit more. So I will present you today how we are dealing with the SIOS core data and core data candidates, and also what are the procedures for the SESS and access code data. So why SIOS core data? SIOS core data has been defined to optimize the resources contributed by the SIOS research community. The core observational program of SIOS should provide the research community with the systematic long-term observation, yet flexible enough to integrate upcoming new methods and research questions. The SIOS measurement program and hence also core data should be continuously monitored. And from this point of view, it's necessary to update the list of the core data using the SESS report or infrastructure optimization report or internal discussion. So we would like to have a visible product that is relevant for the scientific community and useful for the Calvar activities and for modeling. But what is the difference between the core data and core data candidates? The simplest one is that the SIOS core data are available online and accessible through our SIOS access portal. The data sets that are in the preparatory phase, the data that have been collected but not yet made available, we are calling them the SIOS core data candidates, and we are supporting to prepare this data in the FAIR format and make them visible and accessible for the community. But the core data need to require some requirements. The Science Optimization Advisory Group, SOAC, with the task force, defined for the core data criteria that must be met for data to be qualified as core data. This criteria are based on the standard of scientific excellence in earth science, SIOS legal framework, and SIOS data policy. So SIOS core data has to fulfill the criteria of scientific requirements, members' commitment, and data availability. So scientific requirements to classify the variable as a core data. The variable must be critical to answer the key research questions as defined in SIOS infrastructure optimization report, and further update the SESS report. The requirement for temporal and spatial coverage varies between variables and can also depend from the scientific questions. And this was taken into account in the scientific requirements. So we need to have an institutional willingness to discuss and adjust measurements, strategy, protocols in relation to the SIOS optimization effort, to work on the common protocols for the measurements, observation, and data format. For the scientific requirements, the core data are in the close connection to the essential climate variables defined by GCOS. I will come back to that later, and also with the global change master directory keywords, GCMD keywords, that help us to locate our core data in the system. The second requirement is the members' commitment. For core data, there should be more than 5 years commitment from the providing institute to maintain the measurements and make the data available through SIOS data management system. SIOS membership is based on a non-binding agreement. However, for members, there is a very strong requirement to sustain their credibility in the system. So we need this commitment. For data availability, as I said, the SIOS core data should be available through SDMS as soon as possible. Data must be described with the rich metadata, where possible existing measurements and calibration protocols should be used to secure comparability. Instrument comparison are highly recommended. So we are working on the promoting the protocol harmonization, calibration, etc. But of course, it's a long process. And we know that we cannot do it at once for all variables and all systems. So we are trying to do it step by step. And we start this process on core data workshops. So as a result of the last year work, we have defined the 51 variables, which have been classified as the SIOS core data. And then they have been divided into the 4 domains: atmosphere, cryosphere, terrestrial, and ocean. Going into some details, making a mapping of the commitment from our partners, we can see that 20 of 24 of our partners can deliver the core data. So they have a long-term monitoring on Svalbard or around Svalbard. At this moment, 16 of them commit and engage to deliver the core data or core data candidates. The coverage of the variables is not full. As you see, 29 of 51 variables are available as core data and 37 of 51 as core data candidates. All this information are available also on our web page. I will switch there. Yeah, so all this information is available also on our web page. So you can go easily to optimization, SIOS core data, and you will be able to further information about the core data documentation with the full description about the requirements and strategy for the core data. In the Appendix 1, you will find a list of the core data, the first list of the core data, with the core data, GCOS and GCM, the hierarchical structure, and also GCOS and GCMD definition where it's possible. We spent some time on the last workshop to define our own definitions, but not reinvent the wheel, just use the definition that are proper for the SIOS community. So if the scientists agree that, okay, GCOS definition is better than GCMD definition, they're using this one, or they adding some additional information about the units or others. In the SIOS core data mapping results, you can find the detailed information about our partners and who is committed to which variables to collect, both the core data and core data candidates. So all this information is open. Also, the list of the new variables that have been proposed during the last workshop, and Polar Night will come back to that. Below in the materials from the workshop, you can find the presentations from our previous workshops, also some recordings. And for the SIOS core data curation call, you can find information how we can financially support transformation of data to being the core data. So the previous call has been ended at the end of 2020, and the new call will be open today. So you are welcome to check the conditions of the new call after our training. But coming back to the presentation, yeah, so you can find a lot of information about core data on our webpage. And as I said, they are strictly connected to the GCOS essential variables, which probably you are familiar. I will just maybe show very shortly the web page where you can find the information about the essential climate variables. Of course, the core data are not connected only to the essential climate variables, but also to the ocean climate variables, to the biodiversity climate variables, and others. The main difference between the essential climate variables and core data is that if you will go into the details about the essential climate variables, you will see that quite often they are related to the products, not to the single observations of the single variable. So it's a little bit different than what we are doing. It's especially in relation to the remote sensing data. But as it's possible, we are following the standards from GCOS in relation to the units, the resolution, or the protocols for measurements or protocols for the data formats. Yeah, so the essential climate variables, they are physical and chemical or biological variables, or a group of linked variables that critically contributes to the characterization of the Earth's system climate. So GCOS have currently 54 essential variables. As you remember, we have 51 for Svalbard, but it's a living document. And essential climate variables are identified based on the criteria of relevance. The variable is critical for characterizing the climate system and its change, the feasibility, observing or delivering the variable on a global scale is technically feasible using proven scientific understanding methods, and cost effectiveness. So you can see it's in quite good cooperation with the requirements that we have for the core data. Yeah. Going in some details about the core data, you can see here the list of the variables that are connected to the atmospheric domain. You can see that we have very nice coverage. The yellow coverage is the core data. The orange color we have marked the core data candidates. On the purple, the core data. And it's quite obviously there is a lot of meteorological observations. And for many of these data sets, we have overlapping of the measurements from different partners. So one of the goals of the optimization of observation on Svalbard base of core data will be to have a spatial distribution, better spatial distribution of the observations and to close some gaps. Below you can see there are some new variables that have been proposed during the workshop and during the Polar Night Week, and we are now working on preparing the new updated list of the core data and to make an evaluation and remapping of our partners' commitment, especially after the first year, when we will check what of the promised data are available and what is the use of our core data creation code. But as you see, the further we are going into more details and not as popular, let's say popular variables are the atmospheric one, we have less available data. For the data relation to the chemical composition of the atmosphere, you can see for some basic we have available data. But for some of them, they are also core data candidates. So it means that these data are not available anywhere in any repository. They are in somebody's desks or on some private hard drives. But as it's the site, it's important data for the scientific community. So we will be working to make this data available. And you also can see that we still have some gaps. So we have some variables that have been defined by the specialists that they are crucial for Svalbard. It will be worth to have measurements of them and make them available, but no one commits to them. So this is something also on which we can work further. For the data related to the cryosphere, so the measurements on the glacier, on the permafrost, you can see that quite nice coverage of the variables. And you see some also some gaps. You can see here it's permafrost. And of course, we have a lot of measurements of the permafrost in the boreholes and some shallow drilling. So the reason why it's not marked here is that there was some discussion about the definition of the permafrost, what we really measuring. So now it will be a little, this definition will be a little bit changed. So hopefully we'll cover all the variables related to the cryosphere. And as you see, also some new variables are defined. For the terrestrial domain, as you see, we have only one variable now. It's a soil moisture, water content, but some new variables are also proposed. The main problem is with terrestrial and biodiversity measurements is that we are cooperate very closely with the COAT. So they are establishing their own repository. When it will be ready, SIOS data management system will harvest all these data sets, and then we will start a discussion which of them should be tagged as a core data. So then this list will be much more bigger. Going into the last domain related to the oceans. You can see that we are covering almost all of the variables. There is some gaps in the sea level rise, which was discussion about the definition, and also ocean budget heat or sea state, but most of them will be cut due to not clear definitions, or there is no one around Svalbard that can measure these parameters, and it's not really sure if it's relevant for a SIOS community. So, as you can see, there is still work on adding the new variables. The perfect situation is when some of the any of the SIOS members institution commit that they will propose this variable, but also they will deliver with this data in time manner. I think that interesting will be have a short overview about the results. What SIOS community are looking for to work with work on core data. You can see that people are interested in standardization of and harmonization of data formats, as well as standardization and harmonization of measurements protocols. There is not so interest in the calibration, as we are trying to push a little bit this problem, as if we would like to have comparable data sets from the different instruments and which will be defined as the core data, they should be calibrated properly. But I think that we have a lot to do with that. But our first step to work with was to start discussion about the measurements protocols. So for each domains, we have a 2 short workshop, and interested scientists looks into the details about the measurements protocols, already existed standards, and how they can be combined and implemented by the SIOS community. So we have some good progress in that, and as you see, the most of the community are interested in developing the common standards or just to implement it to their measurements. So let's go take the next step in relation to the SESS report data and access code data. The data that have been generated using the SIOS infrastructure, both metadata and data, have to be submitted to a data center integrated with the SIOS data management system. And when non-SIOS data are using the SESS report, metadata and the URL to the dataset have to be provided to the data management system through the metadata collection form, which we will be looking into today. It's important to note that using the metadata collection form doesn't exempt you for sharing data in the open repository. The metadata data collection form is used to make the data findable and accessible through the SIOS data access portal. If the data are stored in the repository that are not connected to the SIOS data management system. And the type information about how to deal with the SESS report data and call data, beneficiaries or authors, they can always find in documents that are add to the call text guidelines or instruction for authors. Starting with the previous SIS report, now there is a mandatory table for all the authors in the SIS report when we are collecting the information about data that have been used in the SIS report. So we would like to have information about the data set and which parameter have been measured, the period, location of the measurements, and what is very important, the metadata access URL and dataset provider. So of course there are different strategy how to do it, but the perfect one is when you have all the data set are accessible to SIOS Data Access Portal, and we are helping to do it for all the data sets that have been generated using the SIOS course or have been used for the SIS report. And as you can see, there are different strategies for that. Sometimes data sets are located in the portals that are connected with the SIOS management system, like Pangea or data repository from Polar Institute. Sometimes there are data sets like Zenodo, and then we are using the metadata collection for. So the strategy how to deal with those data generated by access call or SIS report is that we need to submit data. If we cannot submit it through the to the connected repository, we can use the metadata form, and at the end we should use the observation facility to deliver the information about the facilities that and instruments that have been used for these measurements. So if it's possible, our partners should always use the repository that is connected to a SIOS data management system, and there is more and more repositories that are suitable for that. If it's not possible, you can always contact with us and we can help you to choose the proper repository. But as I said, it's not always possible. Sometimes some institutions have some internal servers, even if they are open, quite often they haven't got a proper discovery metadata, or they haven't got a proper description. So it's really hard to find this data. And then we are starting to use the metadata collection form. It's important to remember for use it, you need to be logged and register it. And you can find this this service under the services data management and metadata collection form. Why collect all the metadata? The purpose of metadata is to ensure that data are easily found and used by users not necessarily familiar with data. In order to achieve this, we need data to be properly documented using discover metadata and use metadata. The purpose of discover metadata is to make data searchable in the SIOS data management system. Discovery metadata are similar to library index cards, basically describing who measured what, where, when, and where data is located, how the data can be accessed, and what can be done with them. The purpose of use metadata is to describe the actual content of data through standardized naming convention ontologies for variables, units, missing values, etc. SIOS has some guidelines on this issue, and whenever the data has been generated using SIOS infrastructure, both discovery metadata and actual data have to be submitted, as I said before. So going into details about how the discovery metadata, for SIOS looks like, and what are the requirements, we can look here into the details. So we have our title and abstracts, principal investigator, email, institution address, dataset start date and time in ISO standard, and geographical coordinates. On the second part of the metadata description, we have the ISO topic category. They are standardized, they are available online, so it's quite easy to choose them. I know that it will be hard for you to see them, but it will be accessible for you when I will make this PDF available, and they are quite easy to find on the internet. One of the most important part in the discovery metadata is GCMD sends keywords, which help us to make the data more interoperable. Let's skip. Yeah. So what is the global change master directory keywords? GCMD keywords are a hierarchical set of controlled Earth system vocabularies that help ensure Earth science data, services, and variables are described in a consistent and comprehensive manner and allow for the precise searching of metadata and subsequent retrieval of data, services, and variables. Initiated over 20 years ago, the GCMD keywords are periodically analyzed for relevance and will continue to be refined and expanded in response to the user. I will show you how we can join to that. And the Earth System Science keywords have a six-level keyword structure, which the option for a option for the seventh uncontrolled field. Category and topics levels define how the keywords are organized and the associated Earth science discipline with the hierarchy. The term and variable level define the subject area, measured variable parameters, and the hierarchical type relations, relationship to the subject area. So if we will look on the web page, which link is also available for you in the presentation, you can easily have access to all the information about the GCMD keywords. And from here, you can download the table that looks like that. So here you can find the newest list of the GCMD keywords, version number 10 from the 15th of March. So as you can see, they are divided into variable level with the term, topic, term, variable, and for each of them, you can also have a unique identifier. So if you will describe your data set, the discovery metadata, or in the metadata which will be into the NetCDF, if you will have the proper link to the GCMD keywords, it will be very easy to use those data sets by different repositories and different portals to make them findable, accessible. I think that is one of the easiest way. But how we can also join to that? There is a, let me see. Yeah. There is a GCMD keywords community forum. So you can have very good cooperation with the scientists from the whole world there. And if you are trying to submit some new data sets or some new variable that you cannot find in the GCMD keywords, you can easily contact with them, and then they will prepare the proper string for your data sets. So every time when we are trying to describe our variables, our measurements, and have a proper keywords, it's worth to check the GCMD keywords to not have our new to not have the new description or re-enter the wheel, but just to use the proper standards. Okay, going back to our description. So the next part of the discovery metadata that we are using have a description of the URL of the data or the data center. We define the data set citation, version, and of course information about the project long and short name. If it's possible, also the quality statement and information about the license. So if you will look, some of this information that we are delivering to have a proper description of the metadata are following, of course, the standards. And we are using quite a lot of standards from the VIGOS to have a proper description of the localization. So here you can see the standardized codes for the dataset production status. So you can choose from open to registered user only, registered user only by manual or automated approval, restriction to a community, or access only to the metadata. And of course, it depends what type of the repository, in which type of the repository the data are stored. As you know, it could be, it varies. And of course, as following the FAIR principles, we always try to follow the open repositories, that it's not necessary to have a full registration. The next standardized description is access constraint. This is, yeah, is the activity type. So we can choose the platform on which the data sets have been collected, from aircraft to ships, or fixed or floating station on terrain, or on the ice. So this list is also from time to time updated, so it is worth to check it, what is the current state. But if you are using our metadata form, you will always find the newest list of that. Okay, so my idea is that we'll go into some smaller breakout rooms. Maybe before that, I will just show you how the metadata collection looks like. So you will have possibility to go to the services, data management, and metadata collection form after you will be logging. And then you will go through the whole process of registering the data in our portal. So for the collection, you can choose if it's relevant, what type of the data would you like to submit to the metadata collection. It's important. Here you can find the guidelines for metadata and data sharing. So part of the information that I have present on my presentation will be available here. So some of the fieldworks are mandatory. Observation facility, it's something that is in relation to our observation facility catalog. So if observatory have, if the facility have been already registered, it will be available here. So you can make a direct link between the catalog with the facilities with the data sets. Sorry. Then, as I said, then we have, for example, title, abstract, principal investigator, some additional information, and what will be, I think, interesting is here when we need to add the GCMD keywords, and it usually works that if you will start to salinity, if you will start to write the name of the variable, you will receive the whole string, which you can use to describe your data sets. Quite often is that you are able to just choose one or two of the strings, and then you should choose as many as it's possible, that it will increase findable of your data sets. Yeah, and some additional information about the datasets production standard. This is planet in work, or activity type, or the platform. And as important, there is necessary to have a link to the data page with datasets. So, but as you know, there are different datasets and there are different repositories. So we are always changing with different problems. Yeah. So analysis ready data. What is this? This is the data that have been processed to allow analysis with a minimum of additional user effort. So it's often said that 80% of data analysis is spent on the process of cleaning and preparing the data. Analysis-ready data sets should be responsibly collected and reviewed, so that analysis of the data yields clear, consistent, and error-free results to the greatest extent possible. When working on a research project, we need to take steps to ensure that our data is safe, authentic, and usable. Therefore, the Earth system, Earth science analysis-ready data for research and application, there has been some procedures for many years. The definition of analysis-ready data has changed over time. And currently, Earth Science area is usually defined as data that is well calibrated, has a good geolocation, and is in a well-documented self-described format like NetCDF, and has a good metadata and is easily discoverable and accessible. In many cases, this data is also gridded and may be spatially and temporally aggregated. The data producers makes many choices when deciding various parameters for these products, such as the grid specification, the temporal aggregation approach. But the goal is to select these parameters to make the products useful to the end user, but also to minimize the number of volume and products stored. So you can have something like steps how you can create the analyze-ready data. So creation of the data, validation, formatting, proper formatting of the data, and validation that ensure that data is collected correctly, prevent the entry with some gaps or with some gaps. The next step is standardization that ensures that data is internally consistent. The same format, the same element in the whole collection. The cleaning is important before analyzing your data to review the data sets, inconsistency or sensitive data. And the last step is documentation. So before you reshare your data, you need to have a proper description of the metadata, user metadata or discovery metadata that follow the proper standards. Of course, there is a lot of challenge to preparing the analysis-ready data. There is need of integration of data across different providers, communities, on languages for data consumption. There is a need to combine different type of data from in situ measurements, remote sensing, numeric channel simulation, and this is supported with the ARD. So it's important to use the self-describing data formats and follow the proper standards. But for the analysis-ready data, I'm not really an expert in that, and I think I found a really nice webinars and some additional papers that you will join and receive some more information about that, especially that there is a lot of efforts now to use the analysis-ready data for the remote sensing products. So I will share with you all these links if you are interested in this topic. So going to the end of our training, we can just look on the recommendation that SIOS can give you. So one of the best one, use the repository that are connected with the SIOS data management. They mostly follow fair principles and fair standards. If you are trying to prepare your own data, it is wise to use the SDMS interoperability guidelines that you will find an easy solution for your metadata description that will follow proper standards, and find some guidelines about the data format. But what is interesting and really nice, I found a really nice sentence that could be useful for our future thinking about the data, is the challenges. We need to switch from 80% of human effort of messaging and playing with data and 20 on use of it to the opposite. It's a long way to do it, but I think that a lot of people making their efforts to reach that goal. Yeah, so I think that I was much more faster than I was thinking that I will be. So sorry for that if I was too fast.